Hi students, today we are going to discuss about software testing, which is our fifth unit in object oriented software engineering. These are all the topics we are going to see in your fifth unit, software testing and maintenance. First we will learn what is the testing. Testing is the set of activities that can be planned in advance and conducted systematically. Testing is the process of finding difference between the expected behavior specified by system model and the observed behavior of the implemented system. The goal of testing is to find errors, and a good test is the one that has the high probability of finding an error. Testing is an attempt to show that the implementation of the system is inconsistent with the system models. The goal of testing is to design that exercise defect in the system and to reveal problems. Testing is usually accomplished by developers that were involved with the constructions of the system. So, we will see two important factors of testing. The first one is the reliability. The reliability of a system is a measure of its ability to provide a failure-free operations. Software reliability is the probability that a software system will not cause system failure for a specified time under specified condition. The next one is failure. Failure is any deviation of the observed behavior from the specified behavior. A fault also called as defect or bug. There are many strategies that can be used to test software. At one extreme, you can wait until the system is fully constructed and then conduct tests on the overall systems in hope of finding errors. This approach, although appealing, simply does not work. It will result in buggy software that disappoints all stakeholders. At the other extreme, you could conduct tests on daily basis whenever any part of the system is constructed. This approach, although less appealing to many, can be very effective. Unfortunately, some software developers hesitate to use it. What to do there? A testing strategy takes an incremental view of testing, beginning with the testing of individual program units, which we call it as unit test, moving to test designed to facilitate the integrations of the unit, integration test, and culminating with the test that exercise the constructed system, which we call it as system test and the acceptance test. So, first we will see what is unit testing. Unit testing focuses verifications effort on the smallest unit of software design, the software component or module. It is performed on standalone module to check whether it is developed correctly. There are three motivations behind focus on these building blocks. First, unit testing reduces the complexity of overall test activities, allowing us to focus the smaller unit of the system. Second one, unit testing makes it easier to pinpoint and correct faults given that few components are involved in the test. The last one is unit testing allows parallelism in the testing activities, that is, each component can be tested independent of the others. So, unit tests are illustrated in the figure. The module interface is tested to ensure the information properly flows into and out of the program under test. Local data structures are examined to ensure that data stored temporarily maintains its integrity during all steps in an algorithmic executions. All independent paths through the control structures are exercised to ensure that all the statements in a module have been executed at least once. Boundary conditions are tested to ensure that the module operates properly at boundaries established to limit or restrict processing. And finally, all error handling paths are tested. Unit testing is normally considered as an adjunct to the coding step. The design of the unit test can occur before coding begins or after source code has been generated. A review of the design information provides guidance for establishing test cases that are likely to uncover errors in each of the categories discussed earlier. Each test case should be coupled with a set of expected results. Because a component is not a stand-alone program, driver and stub must often be developed for each unit test. In most applications, a driver is nothing more than a main program that accepts test case data, passes such data to the component and prints relevant result. Stub serves to replace modules that are subroutine by the component to be tested. A stub or dummy subprogram uses the subordinate module interface, may do minimal data manipulations, print verifications of entry and return to the module undergoing testing. Any engineering product can be tested in two ways, black box testing and white box testing, which we will see in our next video. Thank you.